Independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. Welcome to The Explainer. Today, we're taking a really deep dive into the fascinating architecture behind Akamai Download Delivery. If you've ever wondered how the internet manages to instantly deliver massive software updates or gigantic game releases to millions of users all at the exact same time without, instantly melting down, you are absolutely in the right place. We're going to unpack the entire strategy, the underlying engineering, and frankly, the sheer scale that makes global file delivery actually work. Independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. Okay, let's dive into this. Here is the roadmap for our journey today. We'll start with the massive file challenge, then get into Akamai Download Delivery Explained. After that, we'll look at the intelligent platform edge, peek at the architecture under the hood, and finally, check out global scale in action. Section 1. The Massive File Challenge. Think about what happens during a highly anticipated global software release. Millions of users hitting download at the exact same second. With traditional, centralized delivery architectures, this creates a literal nightmare. You get severe network congestion, astronomical egress costs as data just floods out of a single public cloud location, and ultimately, crushed origin servers that just cave under the spike in demand. But hey, as end users, that's really not our problem, is it? We expect a completely frictionless delivery experience. We want fast downloads, instant updates, and high completion rates, whether we're grabbing a tiny app or a massive operating system update. Bridging that huge gap between traditional delivery failure and our frictionless expectations, that's exactly the challenge we're tackling today. Section 2. Akamai Download Delivery Explained. So, officially, the solution we're talking about is Akamai Download Delivery. This is a highly specialized, high-performance content delivery network, or CDN, solution, and it's built entirely on the globally distributed Akamai Intelligent Platform. Now, keep in mind, this isn't just some generic pipe for internet traffic. It's specifically engineered to provide incredibly predictable, high-quality download experiences while knocking out the massive distribution goals of global enterprises. So, the crucial point is that 100 megabyte threshold. While standard CDN configurations are, they're great for small web elements like HTML, CSS, basic images, Akamai Download Delivery is highly optimized specifically for large, file-based content exceeding 100 megabytes. When you're dealing with files of that magnitude, the very physics of the internet completely change. Latency becomes a huge issue, packet loss hurts way more, and connection stability is just absolutely paramount. This solution is purpose-built for that exact heavy lifting. Section 3. The Intelligent Platform Edge. To really understand how they pull this off, let's use a warehouse analogy. Imagine a company trying to ship a massive hit product globally from just one single central warehouse. During a huge rush, that facility gets completely overwhelmed, the roads outside gridlock, and shipping takes weeks. That's traditional delivery. Now, instead of that single point of failure, imagine having hundreds of thousands of local neighborhood distribution hubs all around the world. That is the Akamai advantage. They leverage approximately 239,000 servers spread across 139 countries, embedded deep within nearly 1,600 unique networks globally. By pushing content out to these extreme local edges, Akamai completely bypasses the notoriously congested middle-mile bottleneck of the internet. They're putting the content practically in your own backyard. Section 4. Architecture under the hood. Okay, let's actually trace the journey of a massive file here. It all starts at step 1, the customer's origin server. This is home base, where the original file lives, but the entire goal is to protect the server at all costs. So we move to step 2, a parent's cache layer. From there, the file is pushed out to step 3, the Akamai Edge server, which lives in those neighborhood hubs we just talked about. And finally, we reach step 4, the end user. When you request a file, you aren't talking to the origin server halfway across the world. You're talking to that local edge server right nearby. This multi-layered approach is the absolute secret to their massive global scale. Now, what's really interesting about the slide is a feature called Advanced Cache Control. This is the underlying intelligence dictating exactly how those edge servers behave. Instead of just blindly passing every single user request all the way back to the origin, the edge server intelligently caches the file. Think about it. If one user in a specific city downloads a massive patch, the edge server grabs it and holds on to it. So when the next 10,000 users in that same city ask for the exact same patch, the edge server just delivers it directly. This drastically offloads traffic, completely shielding that fragile origin infrastructure from getting totally crushed by millions of repetitive requests. But how does the edge get the file in the first place? That's where tiered distribution comes in. Let's say you have 1,000 edge servers all suddenly realizing they need a newly released game file at the exact same moment. If they all ask the origin server, yeah, it would still crash. So tiered distribution acts as a middleman, an additional parent caching layer. The origin only ever has to send the file to a few highly connected parent caches. Then, those parent caches take over and distribute the file to the thousands of edge servers. It's just a brilliant extra layer of origin protection that further optimizes performance and practically slashes cloud egress costs for the customer.
Section 5. Global Scale in Action.
And this brilliantly illustrates where this technology proves its worth in the real world every single day. We're talking about absolutely critical primary use cases, when major operating system vendors push massive software distributions, or when giant studios execute those high-stakes video game releases where terabytes of data are requested in mere seconds. They rely entirely on this architecture. It's also vital for critical security patches. When a bad vulnerability is found, a massive patch needs to reach millions of devices globally, flawlessly, and without a single delay. This is where the architecture stops being just a neat technical concept and literally becomes a critical lifeline. Because the stakes are that high, reliability is completely non-negotiable. This architecture is backed by a 100% availability SLA. Seriously, 100%. This means Akamai guarantees that download delivery will serve content all the time, without fail. When you eliminate those single points of failure at the origin and distribute the workload across hundreds of thousands of independent servers worldwide, you create an incredibly resilient environment. Local outages simply route around themselves, ensuring ultimate reliability for the end user every time. And the business impact of this is just profound. Take a look at this quote from Dave Burden over at Cognos, an IBM company. He states, "Not only has Akamai helped us save lots of money, but it helps us eliminate planning and constant upgrades to support our 30% annual growth in download traffic." That perfectly hits the nail on the head. By offloading the massive weight of those downloads out to the edge, companies completely stop paying those astronomical public cloud egress fees. And even better, they no longer have to constantly buy and provision more servers just to keep up with user growth. The network effortlessly absorbs that scale for them. Which leaves us with a pretty powerful thought to wrap up on. We've seen how combining the intelligent platform, advanced cache control, and tiered distribution completely rewrites the physics of file delivery. So I leave you with this. How will moving your massive workloads to the distributed edge transform your next global release? Just think about the friction you could eliminate and the origin infrastructure you could absolutely protect. Thanks for joining me on this deep dive into Akamai download delivery. Keep exploring, and I'll catch you on the next explainer.